Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the confidence interval on proportion. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. Let's start with an example. In a random sample of 316 karate students, 118 were female. Construct a 95% confidence interval on the proportion of karate students that are female. When reading this problem, how do you know what to do? What are the directions? How do we know it's not a different type of problem? Well, the first thing you should notice are the directions construct, confidence interval. Those are the typical words that you will see when we're doing a confidence interval. So we know that we're doing a confidence interval. We at Walters State do two types of confidence interval, one on the proportion and one on the mean. So what follows the words construct a 95% confidence interval? Notice the phrase on the proportion. It uses that phrase. So we now know that we're doing a confidence interval on the proportion. And now we know what type of problem that we're doing. Here is the same problem at the top of our page. And when we're doing one on proportion, the first thing we need to find is X in P hat and Q hat. Those are typical things we find when we're dealing with proportions. X is our number of successes. In this case, being a success is being a female student, the proportion of karate students that are female. So we want to know X, which is the number of females. That would be 118. N would be the total number of students that were sampled, and that would be 316. The proportion, or P hat, is the probability of success, or the proportion of successes that we have from our sample. That would be our P hat, and that would be 118 successes out of the 316 students. And rounding that to 3 decimal places gives us 0.373. Q hat then is 1 minus 0.373, which gives us 0.627. So we have our P hat at 0.373, our Q hat at 0.627, and our N at 316. For Mrs. Borlaug, rounding P hat and Q hat is to 3 decimal places. For other teachers, you will need to check for the rounding rules that they use. The second step is to answer your question about whether it is Bell enough. Can the binomial distribution be approximated reasonably well by the normal distribution? Is it Bell enough? Remember that Mrs. Borlaug uses N times P hat and N times Q hat. 316 times 0.373 at 117.868 is greater than or equal to 5. Check. 316 times 0.627 as N times Q hat is 198.132 is greater than or equal to 5. Check. Other teachers will use the formula N times P times Q greater than or equal to 10. If that's the formula your teacher uses, then you will need to use that formula. But is it Bell enough? Since both are greater than or equal to 5, it is Bell enough, and we can proceed to the next step. And that is to construct our 95% confidence interval on the proportion of karate students that are female. At Walters State, you will be given the formulas for this procedure, but you will have to recognize those, at least for most of our teachers. Again, please check with your teachers to verify this. Our error is equal to z sub alpha divided by 2 times the square root of p hat times q hat divided by n. Then we take our p hat and add the error and our p hat and subtract the error to find our upper and lower confidence limits. We're 95% confident, which leaves us alpha at 0.05. Using our table, it is a z because it's a proportion, and our z alpha divided by 2 gives us the area in 2 tails at 0.05, our area in 1 tail, that alpha divided by 2. Confidence limits are always 2 tails. 5% divided by 2 gives us 2.5% or 0.025. And using that column and going down to the 0, we get the z row, not zero, but the z R-O-W, gives us 1.960. And that gives us 1.960 times the square root of p hat 0.373 times q hat 0.627 divided by n 316. As you put this in the calculator, be careful of your parentheses. Parentheses inside the square root will often end the square root before it is supposed to be ended. It is always my best policy to tell students not to use parentheses inside the square root unless absolutely necessary. That way you're not ending the square root before you need to, especially on older models of the TI-83 and TI-84 calculators. If you do need help using the calculators with some of these formulas, please drop by and we'll be glad to make sure that you're getting the correct answers. The correct answer for this formula does give us 0.053. I think I'm talking too fast today. We then take our p hat, which is 0.373, and add our error of 0.053 and our p hat and subtract the error. That gives us an upper confidence limit of 0.426 and a lower confidence limit of 0.320. Don't forget the last step, writing your sentence using either the words proportion or percent. So we have our upper and lower class limits, and you can say with 95% confidence that the proportion of karate students that are female is between 0.320 and 0.426. Again, remembering to follow your teacher's rounding rules for the numbers. I can say with 95% confidence that the percent of karate students that are female is between 32.0% and 42.6%. Notice if you use the word percent, you need to have your numbers as percent. If you use the word proportion, they do need to be proportions, and those are numbers or decimals without the percent signs. Here are some exercises for you to try and some partial answers, not the sentences, but just some numbers to check to make sure you're on the right track. And as always, if you're doing these for credit, you will need to show all work to receive all credit. Thank you for watching, and as always, if you are a Walter State student and need additional help, that can be found by coming by the Math Lab in MBSS room 222 here on the main campus. Thank you for watching.